Our lesson for today is all about the equation of a circle. Our objectives in this lesson are, first, for you to illustrate the center radius form of the equation of a circle, and second, for you to determine the center and radius of a circle given its equation and vice versa. Just so you know, circle has two equations, namely standard equation and general equation. In this figure, the center of the given circle is located at point HK and with a radius of r. Given that, the standard equation of circle with center at point HK and a radius of r units is the square of x minus h plus the square of y minus k equals r squared, and the general equation of circle is x squared plus y squared plus dx plus ey plus f equals 0. To make it more clear, if we have the standard equation of a circle, the square of x minus h plus the square of y minus k equals r squared, we can determine the center of it as well as the radius. The center is at point hk and the radius is r. Moreover, if we have the general equation of circle x squared plus y squared plus dx plus ey plus f equals 0, where d, e, and f are all real numbers, we can also determine the center and radius of it using this formula. For center, negative d over 2, negative e over 2, and for the radius, that is 1/2 the square root of d squared plus e squared minus 4f. In this video, we will be taught on how to determine the equation, both the standard and general, given the center and radius. Also, we will be taught on how to determine the center and the radius given the standard and general equation. Now let's get started. Problem number 1 is, what is the equation of circle with center at point 27 and a radius of 6 units? In solving this, we have to first know what is being asked, what are the given, and write the standard equation of circle. Based on the problem, we are asked to find the equation of a circle. In this video, we will find both the standard and the general equation. Next is the given. In the problem, the given are center, which is at point 27, or h is equal to 2, k is equal to 7, and radius, which is 6 units. Then, the standard equation, which is the square of x minus h plus the square of y minus k equals r squared. Then proceed to substituting the given values to the standard equation. So we're going to replace h, k, and r by their corresponding values. So we replace h by 2, k by 7, and r by 6. So this is now our equation with center at point 27 and radius of 6 units. However, we can simplify this. 6 squared is 6 times 6, which is 36. So instead of 6 squared, we write 36. Therefore, our standard equation can be this one or this one. Since we are through with finding this standard equation, we can now proceed to finding the general equation. Remember this, in transforming equation from standard to general form, we will be using special products, square of binomial. Our standard equation is the square of x minus 2 plus the square of y minus 7 equals 6 squared. To transform this to general form, we need to expand this, and simplify this one. But before that, let's talk first about square of a binomial. A square of binomial in special product has two types. First is a square of binomial having an operation of subtraction. Second is a square of binomial having an operation of addition. In the first one, we have the square of a minus b. So to expand this, we have to square the first term, which is a, so we have a squared, minus. Do not be confused on this. If the operation of the binomial is subtraction, then we use minus. If the operation of the binomial is addition, then we use plus. So since the operation here is subtraction, so we use minus. Next is to get the product of the first and second term and then multiply it by 2. So we have 2 times AB plus the square of the second term b, so we have b squared. For the second one, we have the square of a plus b. To expand this, we just have to follow the same procedure that we did here, where we square the first term, which is a squared, plus. Again, the operation here is addition, that is why we use plus. Next is to get the product of the first and second term and multiply it by 2, so we have 2 times AB plus the square of the second term b, which is b squared. Now let's transform this standard equation to general form. First is to expand this, the square of x minus 2. Get the square of the first term x, and that is x squared. And since the operation here is subtraction, so we will use minus. Then get the product of the first and second term and multiply it by 2. So we have 2 times 2x plus the square of the second term 2, which is 2 squared. Then copy this plus symbol. Next is to expand this and apply the same procedure that we have to arrive here. Again, get the square of the first term y, that is y squared, then minus, since the operation here is subtraction, and then get the product of the first term y and second term 7, which is 7y, then multiply it by 2, so we have 2 times 7y, plus the square of the second term 7, which is 7 squared. Then copy down this equal symbol and simplify this 6 squared. 6 squared is 6 times 6, which is 36. Now, the next step is to simplify the equation. So from this equation, we need to simplify this and copy down the rest. Negative 2 times 2x is negative 4x. 2 squared is 2 times 2, which is equal to 4. Negative 2 times 7y is negative 14y. 7 squared is 7 times 7, which is 49. So our equation becomes x squared minus 4x plus 4 plus y squared minus 14y plus 49 equals 36. Next is to transpose 36. We have to transpose 36, so the equation becomes x squared minus 4x plus 4 plus y squared minus 14y plus 49 minus 36 equals 0. Remember, when we transpose a certain quantity, the sign changes. From 36, it becomes negative 36. So from this equation, we combine like terms. 4 plus 49 is 53, minus 36, that is 17. So our equation becomes x squared minus 4x plus y squared minus 14y plus 17 equals 0. Now we have to rewrite this equation into this form. So this will become x squared plus y squared minus 4x minus 14y plus 17 equals 0. Now let's go back to problem number 1. What is the equation of a circle with center at point 27 and a radius of 6 units? Again, we are asked to find the standard equation as well as the general equation. For standard equation, we have two possible answers. The square of x minus 2 plus the square of y minus 7 equals 6 squared. And the square of x minus 2 plus the square of y minus 7 equals 36. For general equation, we have x squared plus y squared minus 4x minus 14y plus 17 equals 0. Again, in problem number 1, we are asked to find the equation of circle given the center and the radius. But what if we are asked to find the center and the radius given the equation? We will talk that in problem number 2 and problem number 3. Problem number 2 is, what is the center and radius of a circle with standard equation, the square of x minus 2 plus the square of y minus 7 equals 36? To solve this, it is important that we know what is being asked, what is the given, and the standard equation of circle. In the problem, we are being asked to determine the center as well as the radius given the standard equation, the square of x minus 2 plus the square of y minus 7 equals 36. And the standard equation of circle is in the form, the square of x minus h plus the square of y minus k equals r squared. Having all this, we just have to express 36 in the form r squared. 36 is 6 times 6 or 6 squared. Now we have to identify the corresponding values of h, k, and r. H is 2, k is 7, and r is 6. So we can now determine the center as well as the radius. Remember, center is point HK, therefore our center is 0.27 and the radius is 6 units. So that's how we determine the center and the radius of a circle given the standard equation. But how about if the given is general equation? So that is our problem number 3. Problem number 3 is, what is the center and radius of a circle with general equation x squared plus y squared minus 4x minus 14y plus 17 equals 0? The same with what we did in the previous problems. We will identify first what is being asked and what is the given. And in this problem, we need to have the general equation of circle. In the problem, we are asked to determine the center, point HK, and the radius r, given the general equation x squared plus y squared minus 4x minus 14y plus 17 equals 0. Remember that the general equation of circle is in the form x squared plus y squared plus dx plus ey plus f equals 0. Now we have to determine the corresponding values of d, e, and f. d is -4, e is -14, and f is 17. Now to get the center and the radius, we will be using formulas. For center, we have -d over 2, -e over 2. And for radius, we have 1/2 the square root of d squared plus e squared minus 4f. So let's solve. For center, we have to replace this by their corresponding values. d is -4 and e is -14. So this will become negative times -4 over 2, negative times -14 over 2. Then simplify this. Negative times -4 is +4. Negative times -14 is +14. So center will become 4 over 2, 14 over 2. We can still simplify this. 4 over 2 is 2, and 14 over 2 is 7. So therefore, the center of the circle is at 0.27. Now for radius, we are also going to replace this by their corresponding value. d is -4, e is -14, and f is 17. So this will become 1/2 the square root of the square of -4 plus the square of -14 minus 4 times 17. Next is to simplify this. The square of -4 is -4 times -4, which is +16. The square of -14 is -14 times -14, which is +196. And -4 times 17 is -68. So, we will have 1/2 the square root of 16 plus 196 minus 68. Again, simplify this. 16 plus 196 minus 68 is 144. So we will have 1/2 the square root of 144. Now, the square root of 144 is 12. So we will have 1/2 times 12. And 1/2 times 12 is 6. So therefore, radius is 6 units. So that's how we determine the center and the radius of a circle given the general equation. Now that we're through with problem 1, 2, and 3, some of you would ask, where can we apply this lesson in real life? Now, just to inform everyone, every topic in math can be used in real-life situations, and that is why our next and last problem is focused on the application of our lesson in real life. Let's have this. The situation is, The Provincial Disaster and Risk Reduction Management Committee, or the PDRRMC of Sorsogon, advised the residents living within the 10 kilometers radius critical area to evacuate due to imminent eruption of Bulusan volcano. On the map that is drawn on a coordinate plane, the coordinates corresponding to the location of the volcano is 0.34. Now the question is, suppose you live at point 11.6, would you follow the advice of the PDRRMC? Why? Take note that each unit in the coordinate plane is equivalent to 1 kilometer. In solving this kind of problem, it is very important that we understand the problem itself and that we know what is being asked, what are the given, and come up with a way to solve or answer the problem. Upon analyzing the problem, we will determine whether your area is within the 10 kilometers radius critical area or not, given that the volcano is at point 34 and the critical area is within 10 kilometers radius. In the coordinate plane, the red point is the location of the volcano and the blue one is your location. Now, to solve this, we will be using the standard equation. The square of x minus h plus the square of y minus k equals r squared. Replace h by 3, k by 4, and r by 10. So our equation is now the square of x minus 3 plus the square of y minus 4 equals 10 squared. Then simplify 10 squared, so we will have the square of x minus 3 plus the square of y minus 4 equals 100. Now to answer whether you are within or outside the 10 kilometers critical area, we will be using this. Given that you are living at point 11.6, we are going to use point 11.6 as xy. So we will substitute 11 to x and 6 to y. So we will have this. Now, if the answer that we get is greater than 100, it means that you are outside the critical area. And if it is less than or equal to 100, then it means that you are within the critical area. Now, simplifying, we will have 8 squared plus 2 squared, and that is 64 plus 4, which is equal to 68. And since 68 is less than 100, therefore, we can say that you are within the 10 kilometers critical area. Now take a look at the graph of this equation to verify if you are really within the critical area. So that is the graph, and you are really in the critical area. So hurry up and get ready to evacuate. So thank you very much, and I hope that you learned something from this. Always remember that there is always a solution in every problem.